All right, so now that you've had a chance to watch the intro video, I am now on page 2 with you guys, and we're just going to practice, again, getting good at solving these literal equations. And I'm going to take some of what you know and apply it to some of the new stuff, okay? So we're over here, we're starting on number 10. And when we're solving for x, you guys know that x divided by 12 is 3, and you know if you have a denominator, you're supposed to multiply on both sides. So when you multiply both sides by 12, this cancels out over here, and 3 times 12 is, of course, my 36. So in this case, we know that 36 is our answer. Now, when you guys look over here at this problem, we're still going to solve for x, which is the numerator, and we're still multiplying both sides by the denominator. The only thing that happens here is that this time there is no number to multiply by 3. It's just 3 times whatever the denominator is, and that would be x. So this shows 3 times whatever the denominator is would be x. Notice that the y's cancel out on this side, and we're just left with 3 times y. Over here, the denominator was a 12, and since it's a number, we can actually multiply to get the 36. But over here, the best we can say is to get the x numerator, you just simply multiply by 3 by that denominator. All right, now we're on number 11. So again, you have a denominator here of 10, so you're going to multiply both sides by that 10 to cancel it out. Now here, 3 times 10 becomes this 30, and then I bring down my numerator x plus 2. Now, since there's still something up here in the numerator with x, I'm just going to simply subtract 2 on both sides, and that's going to cancel out over here. And again, because I have all numerical values, I'm going to get a 28 for this answer. Now, when we move over here to this side, notice that there is no number anymore for the 10. It's just a random variable y. So to solve for x, what we would do is multiply both sides by y, which is what we did over here. It just happened to be a 10. And since it's not a number, the best we can say is 3y over here. Now I'm bringing down my numerator, x plus 2, and I'm going to subtract 2 on both sides. Over here, there was a number for me to subtract 2 from, but over here there's not. So the best I can say is you're going to do 3 times y, then take away 2, and you'd get your x. You're going to do 3 times y, then take away 2, and you have solved for x. That is exactly what we did over here. We multiplied by the denominator, we took away 2, and we solved for x. All right, for number 12, when we have a denominator of 5, we're going to multiply both sides by the 5, and that cancels out. Of course, 8 times 5 is 40, and then we simply divide both sides by the coefficient of 4. And in this case, we get an x is 10. So again, we multiplied by 5, then divided by the coefficient. Now over here, when we have, again, multiple variables, which makes it a literal equation, we're going to multiply both sides by y, which cancels out. So over here, I'd have 8y. Now the next step is to divide both sides by 4. Now be careful over here, y'all. What is 8 divided by 4? Since 8 divided by 4 is a 2, that's why I have a 2y. Now off to the side, let's just say this 4, let's just pretend it was a 3. So then at this point, let's just say if you had a 3x equals 8y, and let's say you're now about to divide both sides by a number that doesn't go into that 8. So then here, you could see 8y over 3, or you might see an 8/3 y. I'd probably end up writing an 8/3 y. So you might still have a fraction here. Or since 8 divided by 4 was a 2, that's why the fraction went away, and this is our answer. So again, I just wanted you guys to see what would happen if you divided both sides by a number that couldn't go into the 8. All right, now over here for number 13, the heart method should ring a bell from the first video that you guys watched. We're talking about the heart method. So because I have a 5x over here, I'm going to divide both sides by 5. And here, 10 divided by 5 is 2. And 25 divided by 5 is 5. And now, if I just say 2 plus 5, I get my 7. Now, there is something else that might have come very naturally to some of you. If you see the 5x here equals 10 plus 25, some of you might have thought, oh, well, why don't I just do 10 plus 25 and get a 35? And then you've got 5x equals 35. That would work. And then you're just going to divide both sides by 5, and we get the same answer. We get the same thing. Now over here, we could do this because 10 and 25 are numbers to add up. But look what happens over here when you have y plus z. See how there's no way we can add up y plus z? We don't know what the numbers are. So to solve for x, we would just say it's y plus z divided by 5. So my Hart method works. I'm just going to divide both sides by 5. That cancels out over here. I've got x by itself. And so when I do y divided by 5, it'd be a y over 5. And if I do z divided by 5, it'd be a z divided by 5. Either one of these, you guys, is fair game for the answer. It doesn't matter which one. That's why I have an or here. You could write your answer like this or this. If you see it this first way, it is implied that you would do the Hart method and divide both of those to get this answer down here. So it doesn't matter how you want to leave the answer. It's a lot like up here with this example. Some people are going to leave it as 8y over 3. Some people are going to want to put 8/3 y. It's just a matter of preference. So here, either one of these is fair game. All right, so now for number 14. I know you guys are watching this video and taking notes, so you might want to just take the time to draw that cone briefly while I read the problem to you. We are being asked here, what is the height? What we don't know is the height of a cone. We are given the volume, and we are given the radius. So I went ahead and drew the picture. I have my radius here as a 6, and we are given the overall volume. And I went ahead and just wrote in the formula right here. Now we are going to need to find h. So if you're given the volume, I just plugged in the volume right here. And the radius is a 6, and I still don't have h. Notice I just swapped out a 3.14 for pi. So in this line of work, I have simply plugged in the volume and the radius that we're given. Now, where did I get this 37.68? Let me pull up my calculator. If it'll let me, sorry. There we go. All I did, y'all, was multiply 6 squared, so I know it's a 36, times 3.14. And now I'm just going to hit equals and divide by 3 to take that 1/3. That's where I got the 37.68. So again, I just simplified right here. 6 squared times 3.14 times 1/3. That's where I got this. Now I'm ready to divide both sides by the coefficient. So when I divide both sides, I got h all by itself. 376.8 divided by 37.68 happens to be a 10. So now I can come through here and say that my height is a 10. This would be a 10. Okay? Now, right below it, though, let's see how to go about this if you don't have any numbers. This is where it gets a little bit tricky. Instead of having numbers to plug in and just simplify for h, we need this variable all by itself. Now, getting a new page here, if you happen to have the number, I'm just making this up, let's say you had 1/3 of some number is 8. Okay, 1/3 of some number is 8. To solve for this, you remember that you multiply both sides by the reciprocal. And this cancels out. X is all by itself. And 8 times 3 would be a 24. So if we take 1/3 of 24, we get 8. 1/3 of 24 is 8. Now to solve, though, you saw what I did here on both sides. I multiplied both sides by its reciprocal. So going back to my volume problem, when I want to isolate h, the first thing I'm going to do is get rid of this fraction by multiplying both sides by the 3/1. That now cancels out this. And on this side, I'm just going to have a 3v. So I've got 3v equals pi r squared h. Now you see me dividing both sides by pi r h because pi divides out, or sorry, pi r squared, because the pi cancels out and the r squared cancels out and h is all by itself. So over here, I just leave in the denominator the pi r squared. One of the kind of annoying things in this unit as you guys are writing this is that the final answer is right here already. And it just feels weird to have to kind of write it again below it just to show the answer. So again, from the top, let me just show you guys how to shuffle these letters around if you're trying to solve for h. Okay, this is how it would look if you're taking the notes at home. First thing you're doing is this. 1/3 times 3 cancels out, so I'm left with pi r squared on this side. Oh, and I can't forget about h. H is the whole variable I'm trying to solve for. There's the h. Now over here, we said 3 times v is just 3v. Now I'm going to divide both sides by the pi r squared so that that cancels out over here. And like I'm saying, y'all, as you're writing this, right there is when you're getting your final answer. That is the final answer. This cancels out, and h is all by itself. So it is okay to just put h equals over here. It is okay if you just want to put the h equals over here instead of having to write a whole new line underneath your work. All right. And to check, to make sure, let's just use this example up above. We already worked mathematically to find the height as 10. We now have found a new formula for height. We just shuffled around the letters to make it a formula for height. So if we do 3 times the volume that was given up here, and we divide it by pi r squared, and we crunch the numbers, it should give us the height. And when we crunch these numbers here, it does give us the height of 10. So we know our little new formula that we rewrote to solve for the height works. So this is correct. And now finally, again, just a literal equation. The literal equation is when you're basically shuffling around to make, kind of like we're saying here, a new formula where this variable now represents all these known values. So like if I know the volume and I know the radius, I can plug those in and then get the missing dimension, the height. So that concludes this video now here on page 2. Thank you for watching.